This is the third screencast in Unit 1. We're going to be covering what density is, how to calculate it, as well as how you're going to be working with it in the lab. So this picture here shows you a column of different densities. You should remember that the substance sitting on the top are going to have the lowest density. They're going to be the least dense. We think of a ping pong ball as being something that's has very little density. Whereas the bottom layer here, the honey and probably the lead bolt, are going to be very dense objects. So what is density again? Density is the amount of matter present in a given volume of substance. So basically, it is the stuff present in a given space. So how much stuff is in a certain space? Another way to say it is how tightly packed your particles are. The tighter your particles are packed, the more dense the object is. So this shape on the left here shows particles really tightly packed. There's almost no space in between them. So it would have a high density. Whereas the object on the right, they're starting to spread out. So the more space you have between the particles, the less dense that object is going to be. So again, if you compare densities, your objects that sink to the bottom are always going to be the ones that are the most dense. Their particles are most tightly packed. Your substances that rise to the top are going to be your ones that your particles have the most space in between them. They are the least dense. Calculating density. This is probably an equation that you've used before. So just a recap, density is mass divided by volume. So density is mass divided by volume. If you were to rearrange this equation algebraically, you could get mass equals density times volume, and the final one is volume equals, volume equals mass divided by density. Mass divided by density. Okay, so those are the three versions of the same one. As long as you know this one, you can rearrange algebraically to get the other two. So, given the equation of density, what would be the units of density? Really, it's any mass divided by any volume unit. So, in the metric system, the unit of mass we use is grams. When we measure a volume of a liquid, the unit is in liters, or it can be in milliliters. Okay, so those are both possibilities for units of density. Now, this is only for liquid volume. Sometimes volume can be a solid or a gas. In the case when it is solid or gas, your unit is going to be cubic centimeters. You've probably heard of ordering flooring in cubic centimeters, or maybe receiving air, how many cubic centimeters of air. We're going to talk about that more in a couple slides. But these two are your most common units of density. So anytime you see that slash, you see those two units, it's most likely a density. So this is what a typical density problem is going to look like on your quiz as well as on the Unit 1 exam. So let's run through it real quick. The density of solid silver is 10.5 grams per cubic centimeter. So there's that slash unit. That tells you that it's a density. What is the volume of a 50-gram sample of silver? Now grams we know to be mass. I want to pick the version of the formula that solves for volume. That was the last one we wrote. Mass divided by density. So my mass is 50 grams and my density is 10.5. 10.5. Notice I'm writing my units throughout the whole problem. Because I did this, I can check and see that they will cancel to be the right unit. So grams up here is going to cancel with grams down here. My unit is going to end up being cubic centimeters, which is what we want because we're solving for a volume. So that is 50 divided by 10.5. Comes out to 4.76. 4.76, and again my unit is centimeters cubed. So this is really as hard as these problems get. I'm confident that you'll be able to do the others. Now, when we're working with density in the lab, we're going to be doing a lab where you have to put random objects in order of increasing density. So some of those objects are going to be nice squares and rectangles. When you're working with squares and rectangles, you can get the volume simply by taking length times width times height. That should be an old formula for you. So you can just take a meter stick or a ruler and measure this length, width, height, making sure you're including the estimated digit before you do that. So in this case, it'd just be 6 times 7 times 4. And then you take that value and you just do mass divided by volume to get the density. Okay, so those ones are going to be pretty easy. Some objects I'm going to have you find the density of are going to be very oddly shaped. They're not going to be something that you can measure the dimensions of. In those cases, you're going to use the water displacement method. So in the water displacement method, you're going to start by filling a graduated cylinder to some easy to read amount. It doesn't matter how much, except that you can't have it all the way up to the top because then it doesn't have any space to move. So record the starting water level. Then you're going to drop the object in and record the final level. Finally, you're going to find the difference in water levels, because that's going to be what the volume of the object is. So if the water starts at 10 and then it goes to 15, the object you dropped in it is 5 milliliters. So I'm going to show you a couple easy examples with that. So if we want to know the volume of this dinosaur, we would record our starting level as 4. These are all worth 2 because there's only 5 of them in here. So this is starting at 4.8 milliliters. After we drop the dinosaur in, it goes to 246. It goes to 5.6 milliliters. So the volume of the dinosaur is the difference. 5.6 minus 4.8 is 0.8 milliliters. So the volume of this dinosaur is 0.8 milliliters. Making sure you're using all the techniques of the cylinder, leaving it on the table and viewing the meniscus from eye level. So here's another one. So the water was originally at 3.4. After we dropped the toy in, it was 5.0. So you would find that difference. So that's going to be 1.6 milliliters. That's going to be the volume. So once you have the volume for all of these, you just use mass divided by volume to get your density. Okay? So again, anytime you have a square or rectangle, you use length times width times height to get volume. And anytime you have an oddly shaped object, you need to use the water displacement method to get your volume. Good luck on your lab practical. I'll see you in lab.